So today we're going to talk about ways you can benefit from online or energized maintenance of your power distribution equipment without the significant cost investments. So we're going to talk a little bit about that, why that's necessary, and what ideas there are out there for people. So in 1980, the average productivity of most industrial plants in the US was around 85%. What that means is those facilities were energized 85% of the time, which means 15% of the time they were not energized. That equates to about 55 days a year. So that sounds pretty good in today's terms. You had 55 days a year to do your regular maintenance on your power equipment and your industrial equipment. In 2019, if anyone wants to guess, that industrial productivity jumped to 97%. That means that those 55 days of outage time reduced to about 11. And all that came from Alan Ross, who has been a stalwart of information in terms of reliability and market trending in the energy segment. So that that 55 days to 11 days, a lot less time for maintenance, for outages. And so we have found in our experience that equipment can sometimes become less maintained, or if there is any kind of outage, it's very brief. So it's very limited in what you can do during that outage time. On top of that challenge of having less time to actually perform maintenance, you've got more and more mature facilities. So you have an aging infrastructure. You have more things that need to be addressed or replaced, and you have less time to do it. In addition to this, we have much more awareness of arc flash safety. And so therefore, before where people would cheat and start working on equipment while energized, well, we have a better understanding not to do that. Or at least if you're going to do that, you're going to be suited up and you are going to be limited in what you can actually accomplish. And on top of all that, as the years have gone by, manufacturers have become more and more cost effective in their designs. And really what that means is they've designed more and more margin out of the design. And so therefore the challenge of keeping something extended life is more and more difficult. So with all of these things, this has led to the necessity, so to speak, of online monitoring. And there are several benefits, there's several benefits of online monitoring. You're able to track all your key parameters. You're able to monitor how your key components are behaving and performing. You're able to look at the power quality aspect of the power you're getting in, not just from the utility, but also as you're distributing through your network. And you're also have a variety of communications. So obviously you can have centralized control over your facility or multiple facilities, multiple campuses, depending on your infrastructure. All of these things are very good. And this is essentially the market trend that could very well become the mainstay for most of industrial facilities in the future. However, this does come at a cost. And so if you have a typical substation with a primary low break switch to a transformer to some switchgear that will feed some motors, and we have this as an example. This is our typical, I don't know if typical, but it's average substation. In order to provide online monitoring for the substation, you're going to need the switchgear monitors, sensors. You're going to need your dissolved gas analysis monitor for your transformer. You're certainly going to want to monitor on each of your motors. You're going to need, I mean, 1 to 2 weeks is probably pretty optimistic, but you're going to need a significant shutdown to not just install these sensors and all the wiring, but also the configuration of all the settings you're going to need in your devices in order to properly monitor this. And then you're probably, unless you've got on staff already at your facility, you're probably going to need some kind of third-party analysis assistance in order to do all this. And if you start adding up these budgetary costs, you come up to a pretty good investment just for one substation. This is the reality. This is where we're at today. Hopefully, as technology improves and we can get easier on installing infrastructure, these costs can come down, but for the most part, this is kind of where things stand today. And this is just for one substation. There are plenty of facilities that have multiple. What we're going to talk about today is you know, how to get some of these benefits when you don't have the money to do this. On top of those base costs to get the online monitoring for that substation, you're going to have to also have the IT and communications infrastructure within your company just in order to be able to disseminate this information. You're also going to need training in analytics, diagnostics in order to interpret the data you're going to be receiving. It's probably going to be, you're going to ask someone to do it for you, and that'll be another subscription service. And you're going to need flexible shutdowns, because if you start acting on this information, you might find that your primary switchgear might need attention sooner than you expected. You can avoid a major fault or issue, but you're going to need a shutdown to address it sooner than you're going to need a shutdown to address your transformer or your secondary gear. And so therefore, in order to act on the information you're getting, you're going to need some flexible shutdowns. And then you're going to need, regular software and hardware upgrades, because these devices continually to evolve and improve. So it's a commitment. This online monitoring is a commitment, and it's a good one. It's an effective one for those who are able to make that commitment. But we hear time and again from a lot of our customers, we just don't have the money for that. It's not in the budget, and we understand. So this is where we're going to try and do what we call on-demand monitoring. So it's not really online as much as on-demand. It's when you want to know something, here are some tools you can use. These are not things that we own. We don't own the patents on any of this material. This is just experience and information we have found that would be helpful for customers in these situations. So hopefully some of these ideas might spark an interest in some of you. One is obviously energized oil sampling. Oil sampling has been around for a long time, but energized oil sampling, there are many people who don't have this still. And this is something we want to introduce, coupled with infrared scanning. Also ultrasonic testing, and we'll get into that, what that means. And then also some motor bearing harmonic filtering. These things will end up saving a lot of headache and provide extended life for your equipment. So let's start with the first one, oil sampling. Oil sampling has been around for decades, is a tried and true method of knowing what your transformer's health is like. It's essentially like taking a blood test for yourself. And so this has been around forever. What hasn't been around is the issue of getting the sampling while the transformer is energized. A typical pad mount transformer, and there are many, many, many of them in distribution realm, is by definition tamper-proof. And so everything is locked into a cabinet, and everything is accessed in that cabinet, including the power cables. So you might notice that your sample valve happens to be right here, right below all your energized power cables. So you would and obviously today you'd have to suit up in your proper PPE. Hopefully the incident energy rating of this pad mount does not exceed 40 calories per square centimeter. Otherwise you wouldn't be able to access it at all while energized. If you can access that, even if you're suited up, it is not recommended to sample this energized. You can certainly, but you're so close to these power cables that it would certainly be risky. And so most of the time, sampling requires a de-energization of that transformer. That would be the safest way to do it. But going back to our first slide, those 11 days of outage is all you're allowed per year. So it does make this more difficult to do this sampling. You want to do sampling on a fairly regular basis. So the easy solution is move that valve or extend that valve outside of harm's way. And that's where we would put in a separate valve in its own tamper-proof box that would be mounted on the outside of that cabinet. And by doing that, you can allow yourself to do the same kind of sampling you've always done, monitor your pressure, your vacuum on your transformer without accessing that cabinet, without even having to suit up. And so therefore, this is what that box would look like on a typical pad mount. And these are fairly easy to install. We are part of our company is transformer supplier. We build new transformers, custom transformers for our customers, as well as service them. And we recommend this to anyone who wants to listen to us, because this is just the simplest way, easiest way to monitor whenever you want. You get I guess I call it on demand. You can take a sample every week, every hour if you want to, while the transformer stays energized, and you can monitor the health of that transformer. Is fairly simple to install, fairly cost effective, and allows you to avoid having any kind of unnecessary shutdowns. So couple that, while you're doing your oil sampling, we also recommend customers do an IR, an infrared scanning of that transformer. It's a simple, easy way to kind of get a good feel of the convection going on within a transformer. Usually you're going to see your hottest temperatures at the top, your coolest temperatures at the bottom. And based on this scale and that 117.5 Fahrenheit temperature, this transformer is operating just perfectly. No problems at all, no hot spots, and everything's cycling through as it should. If one of these fans was red near the bottom, we would know that it's not operating, and so therefore we would know instantly, hey, we need to give some attention to this fan in order to get proper cooling. So this is a fairly simple way, again, to, as you're there at your transformer doing your sampling, do a quick IR scan and get more information on how to see if anything unusual is happening. You can also do the same thing for your switchgear, and you can do a quick scan to see if any particular phase is seeing any kind of hotspot, as you see here in phase C of this fuse. So therefore, by doing, if you install IR windows, which we also highly recommend, you can do these IR scans in your switchgear while the doors are closed. You don't have to have the PPE, and you can get this information whenever you want, again, on demand. And otherwise, you're going to be suiting up like this guy in order to take these scans. So these are just quick, simple things to do that have been around the industry, but we keep finding people who have never heard of these or considered incorporating them in their maintenance practices. The next thing we're going to talk about is ultrasonic testing. So traditional maintenance and testing, all of these things, these are usually done by IR scans. the torque and the visual inspection. But in terms of impedances and insulation, those are not available for IR scans. And the only way to test if you've got any kind of difference of impedances, if your insulation is starting to break down, the only way to test this is through electrical testing. And the only way to do the electrical testing is through de-energized equipment. There really is no other safe way. So why ultrasonic testing? Well, this testing, it's a device that measures the disturbances in air, any kind of turbulence, and it measures its frequency, usually on the high frequency realm, well above 1,000 hertz. And this allows you to detect if it's anything, it's airborne, liquid, or gas, any kind of vibration like a loose bolt. And then it also does the electrical diagnostics of arcing, tracking, and partial discharge. And actually, each one of those has its own separate signature. We're going to look at that. And then this device converts those high frequencies into audible sounds. And then it can also record not just the sound, but also the frequency wave, the wavefront. And then through software, you can identify what the likely source of that disturbance is. And all this can be done while energized. So this gives you an extra insight into things the IR scan cannot do, and all of this while energized. So what this looks like is a little device, and you can put it into a port in your enclosure that you can install, or you can do it even through the seams. It's not as good of a signal, but it is still a signal you can act upon. Or you can just simply, when it's the high voltage equipment, you can just point it toward the equipment, and it'll detect those vibrations here as well. So this, again, the ports are probably the best signal quality you're going to get. Background noise doesn't apply when it comes to ultrasonic, because most of the frequencies we're looking at are well above 1,000, actually above 10,000 hertz. And so most audible noise we have is well below that. And so any audible noise that's going on around you is so far left on the spectrum that it doesn't even get recorded. It's not even considered part of the factor. And this allows you to just purify that signal, purify what's going on, and be able to analyze, detect, or identify what the disturbance is about. And then once you do this ultrasonic testing and find out an area where there is a concern, now you can start using your IR scan, and you can hone in on that problem a little more effectively. So we've got a couple of examples, and I'm not going to play these, but because they are kind of irritating to listen to, but you can see this type of signature that you see on your screen actually is corona. And so this is going to be your partial discharge that's going on, your breakdown within your insulation. And this is going to be the signature for it. So if your ultrasonic testing is detecting something within the signature and within this kilohertz range, then you know it's going to be a partial discharge in that enclosure that you're detecting it. Once you know that, then you can start planning your outages to have more detailed inspection of that insulation and replace as you need to. This type of popping and intermittent spikes, this actually is indicative of tracking. So this means that there's a slow decay or slow breakdown of that insulation. And if that tracking continues, it would lead to a phase-to-phase or phase-to-ground fault and could cause significant damage to your equipment. This one happens to be actual arcing that's going on. Obviously, this is a serious situation you would want to act upon right away. So it's great that you can actually distinguish between those three electrical characteristics. And again, all this is done while de-energized. So to do this testing, you would need your IR and ultrasonic testing service. You can buy your own equipment if you want to, or you can just have it done for you, just like you would an oil sample. And for that testing service, it's usually fairly cost effective. If you do it for just for one substation, it's going to cost a certain amount. For a little bit more, you could probably do multiple substations. And then depending on scope, yeah. So that's another avenue to take in order to get some of that online benefit, but not with the cost. The last thing we're going to look at is going to be the voltage distortion and damage we get from harmonics. In most motors today, I would say maybe even the majority of motors that are run in facilities and industrial facilities, at least the larger ones, are going to be or have some kind of harmonic distortion, waveform distortion, usually from VFDs. The drives almost always introduce that distortion. And before, drives weren't as prevalent in industry for running motors, but more and more so, they are seen as a one-for-one for motors. And their presence has greatly influenced and improved productivity in a lot of industrial facilities. But again, there's a cost. There's this distortion that that comes along with it. Because of that distortion, these are some simple rolling or moving bearings, rolling bearings on motors. You can see that etching. If you would rub your finger along that etching, it would feel like a railroad track. That is the harmonic, the high frequency harmonics eating away at that bearing, and that obviously will lead to a bearing failure, which would eventually lead to a motor failure. You could end up damaging the windings, need the motor rewound altogether, or obviously at least replace the bearings. So this is going to shorten the life, definitely, of the bearing. And if you shorten the life of the bearing, you almost always end up shortening the life of the motor. From these transient currents. What we would highly recommend, and we do this to, again, all of our customers, there are a method of filtering out those high frequencies in order to keep that damaging current from even entering the motor. So in your supply line between your VFD and your motor, you would put what we call, well, not what we call, there's a manufacturing company that provides this. It's called CoolBlue, and these are inductance absorbers, and very simple to install. You simply have all three phases of the power cables go through the large, we'll call them donuts or boots, and then you also have individual ones on each cable that are also incorporated. And by doing this, and this is some examples of how these are installed, this is a one-time installation. They are good for the life, generally, of the motor. And here's a sample of the power quality coming into the motor before the CoolBlue is installed and after. It's not 100% filtering, but it greatly reduces. They say they average about 2/3 of that high frequency currents are eliminated after installing these inductance absorbers. And by doing so, you can, again, extend the life of that motor, extend the distance between the required maintenance, and it would pay for itself very quickly. So for that given 800 horsepower motor in our example, you would need these 4, based on that size, you need 4 of these CoolBlue absorbers, and then these NALA cores that go around each cable. They're, again, for the lifetime of the application, so one-time investment, and fairly easy cost, very, very manageable cost for this. So if we go back to our original example, and again, all this is about money. I'm trying to help budgets who want the online benefit but just don't have the significant investment needed to pull it off. You can, we were starting out around 180 to 200,000 in order to properly install online monitoring for this given substation. If you use the examples and suggestions we mentioned, it's not a one-for-one. You're not getting continual monitoring. You're doing it on demand when you want it, but it's for a lot more manageable cost for your budget, and you still get a lot of that benefit that you wouldn't normally have. Obviously, you're not monitoring the motor with this CoolBlue, but you certainly are eliminating a lot of the common problems that we see, because we also have a motor repair division, and these are some of the things we see all the time. And this is why we're always recommending the inductance filtering for it. So that's my presentation. That's the basis of what I wanted to pass by you. Hopefully some of these ideas were of use to you. If not, or if you have any questions or any follow-up, I'd be happy to answer them either here on the webinar or also offline. So with that, I don't know if we have any questions.
Lots of questions, actually. What is the benefit of energized oil sampling?
Well, by doing the energized oil sampling, especially, and again, it's oil sampling itself lets you know the status and the health of your transformer. When it's a pad mount transformer and it's so difficult to get to the sample valve, by doing it energized, you don't have to de-energize your transformer, first of all, so productivity can be maintained, but it also allows you to be able to find out if there's anything wrong with this transformer, any kind of health. We have gone to sites, a maintenance bid, and we say, well, what about those pad mounts over there? Oh, well, don't worry about those. We can't oil sample those. Well, why not? Well, those are critical transformers. They stay energized 24/7. We can never shut them down. So we don't sample those. Well, that's just counterproductive, counterintuitive. If it's such a critical transformer, surely you want to know what the health of that transformer is. So therefore, having the ability to take oil samples while energized would certainly benefit that facility. And there are many other facilities who have told the same thing to us. So I don't know if that helps answer that question.
Okay. What is the definition of regular oil testing? Annually, every 2 years, or every 5 years?
Oh, I would not go anything beyond annual. There's no need. It's so cost effective. There's no need to extend beyond that. So much can happen within a given calendar year. I would definitely recommend annual testing on oil sampling. And then once you start seeing a trend in some of your gases increasing, you would want to do it even more frequently than that. You want to make sure you're seeing, if you're getting any kind of dangerous acetylene or anything else, you want to be able to plan for some kind of outage in order to do oil processing, which can be done on site and done fairly quickly, depending on the size of the transformer. There's no need to extend it beyond a year.
Right. Okay. Is there some type of chart that defines what the ultrasonic picks up, like loose bolts or insulation failure?
Well, yeah, there's each, I gave you 3 examples, but each one of those instances, loose bolt, breakdown insulation, which would be the tracking and the partial discharge, as well as the arcing, all those have unique signatures. And so it is able to distinguish between all of those. The only thing that can throw you off with the ultrasonic testing is if you have 2 different issues right next to each other, and they kind of, you have to really hone in on one. And what you're doing is you're looking for the highest magnitude of your signal as you're going through your equipment, and then where you see the highest, okay, that's where you want to focus on. So if you've got an air leak, a pneumatic air leak right here, a few feet away, and then you've got an arcing going on right here. Those two can interfere and confuse. You want to hone in as best you can. That's where the ports come in handy, and then you can distinguish between the two.
Okay. Can you provide information about the CoolBlue induction filters?
Oh yeah, we can supply cut sheets on those. Again, it's not our own product. We just found this works really well, and it's worth sharing with people. But yeah, I'll be happy to. I can probably send those to you, Randy, if you want to disseminate to others. We can
Sure.
include that in the presentation. Sure.
Yeah, no problem. What standard CoolBlue inductive absorbers define?
I'm not sure I understand the question.
Okay, what is the I guess what is the standard? What is the standard is there a standard that defines CoolBlue induction absorbers? Are they governed by a standard?
That's a good question. I really don't know on the top of my head. That would be something that would probably be in the literature.
Okay, here's one. For the external sampling ports, to have these installed on existing transformers that have internal sampling ports, does the transformer need to be removed from the site to have them installed?
No, not at all. They can be installed in the field. We do that service already. And as we're also a transformer manufacturer, we also supply them in our factory. So yeah, both can be done in the factory or in the field. Not a problem.
Okay, those are great questions and a good presentation. Thank you very much, Ray.
Sure. No
for your
problem.
good work, and thank you everyone for your questions.